All right, guys, we're ready to go again. Here's Luke Smith. After this session, we're going to have lunch across the hallway, and then the sessions after lunch are going to be broken out into two rooms. We're going to be here and also the room next door. So you'll notice that there's 2 tracks for the afternoon. Take it away, Luke.
Okay. Am I coming through the mic? All right, cool. Let's see. Okay, shall we get started? Hi, everyone. I'm Luke Smith. I'm with the SmugMug team that's representing right there's like the whole middle section right there. The awesome guys at SmugMug. Before that, I worked on the YUI team as part of the core team for a few years. And in the past couple of years, it's really odd for me to have the screen so far away. How am I expected to point at stuff? I like to point at stuff. So in past years, I've talked about a variety of different core parts of the library. I started with the event system, and then with the module system, and a bit about the node abstraction. Last year, I talked about the inheritance patterns and compositional mechanisms inside of the library. So this year, sticking with that sort of theme, picking another core part of the library, which is the attribute system. And at first I thought it'd be fairly simple. Maybe it would fit really tightly into an hour. There's not a whole lot there to talk about, because you all know this stuff, right? I mean, if you've used YUI3, which as evidence of you physically being here, you've used YUI3, so you've used this. You already know this stuff, right? There's the get method, the set method. When you're creating an instance of anything, you're passing a configuration object with the overrides for the default values for those attributes for things, right? If you've been building classes on top of attribute or on top of base, then you know the ATTRS collection and the various configurations that are available for setting up your state, right? So what I want to do is not spend an awful lot of time on getting to know what is available, and instead talk about a little bit higher level, why the things are the way they are, a little bit lower level, talk about how they work, and why you would choose certain things over other things, what's best to avoid, what advantages you get, and what the relative trade-offs are, and so forth. So I'll start with the obvious question, which is, what is an attribute, right? And so quite simply, an attribute is an encapsulation of a value, state, and set of whatever. It's an object property with some magic associated, right? That's all it is, right? The whole attribute abstraction is just object.property equals foo. That's it. You have accessing properties, and you have assigning a new value to properties, and everything else is just magic. So what I want to talk about is the magic, right? And so there's an awful lot actually to talk about the magic. There's what it is, why we need it, where it comes from, how it works. And I want to finish it off with that big question of whether or not the magic is worth it. AKA, should I use a property or an attribute? I bet a lot of people in this room have asked that question of themselves, of other people have had those discussions over time. So I want to put in at least some additional context, some additional information to help you answer those questions when you have them, and you'll probably have them again and again. So, starting with what's the magic? At the high level, what it amounts to are getters, setters, and default values. Now we throw in change events as well, and change events are actually a pretty big thing. I mean, you could say that change events can actually be implemented as compositional behavior inside of a setter, right? So you can do change events from inside of a setter. So the magic is really those 3 things, the getter, setter, and value. But if you know what's going on with ES5, which hopefully everybody knows what's going on with ES5 right now, ES5 already has that magic in it, right? So you have object.defined properties, you have defined property, you get to set, you have your default values, you have your getters and setters, and so it's already supported natively in the language, right? So we're done here. Right. So, and we're going to need this abstraction for a long time. And thanks to our dear friend, IE, not going away very soon, or just not versioning very soon. Now, the defined properties is available in IE9. There's a busted version available in IE8, and I've fiddled with it, and it's really fragile, and I wouldn't trust that to production code. But IE9 has it, IE10 has it. It's really just a question of when they go away. So that's the really high-level overview of what it is. So why do we want the magic? In short, because properties are dumb. And I don't mean that in any sort of ad hominem name-calling sort of way. It's just a point of fact. Properties don't do anything. You assign a new value to a property, your attribute, your application has not changed at all. Nothing happens. Nothing, right? More code has to execute after that new value is there in order for that new property value to actually take life in the application. So you don't gain anything by changing a value in a property. Nothing. There's no communication associated with that. Everything that has to happen in your application after assigning that new value to the property is what makes your application work. Properties by themselves are dumb. So you end up having, if you have a class with some properties, so we can go through the history of attribute and the history of how it appeared from YUI2 and manifested through the element class and then into YUI3. But it's a long story, shortened down to you start with a property, and then that property shows up in a couple of different methods. You refer to that property, and then maybe you have to do something in response to that property being changed, obviously. But if you change it over here, then you got to add that same code over there. So maybe you're calling a function over there, and then you've also got to call that function over here where it's also referenced. And now somebody's putting some garbage into your code, and so it has to protect against a certain value type, and then you have to put that value type protection against the other thing, and maybe it was unset, and so you need to make sure that it's not empty, and so on and so forth. And you end up going on to, okay, well, maybe if I just abstract this out to a function, so get foo and set foo. Now you're creating an abstraction layer instead of just dealing with properties in the first place. But that doesn't scale, because now you have set foo and get foo, which hopefully everybody is now using instead of just using the properties directly. But if the properties are there, you know, people are probably still going to be hitting them, or there's going to be some old code that's going to be referencing that property. And for all of the times that you have a new property, you now have a new get foo, get bar, get baz, and so on and so forth. Where if you have a set of behaviors, such as communicating changes to elsewhere in the system, aka events, you're now duplicating all of that code, right? So let's now normalize that down into a get and a set method, right? And then taking in that property. So that's the basic history. But the properties by themselves, by their nature, are dumb. So the number 2 here is maintenance. So when I give that whole history about what happens with properties inevitably over time in your code, when you end up with a system where there's a single method, get or set, and there is an infrastructure to support the various ways that this property is going to communicate and propagate elsewhere in the system, you now have a template for your code and a centralized set of behaviors. So you have your getter, your setter, and your default values, so that when you add something new to your code, you have a way to do it and you have a place to do it. So when something changes in your application, you know where to change it and you know how to change it, and that automatically propagates to the system. Saves hugely in maintenance, right? Okay, so let's talk about where the magic is coming from. The classes involved, there are a number of them. You're most likely going to be familiar with base, because everything, all the things are built on top of base. Base has 3 primary pillars under it, well, I suppose 2 primary pillars under it, and then attribute extras, which is not worth talking about. It has a really small API, it doesn't really do anything. Okay, so base core and base observable. So core is where the lifecycle comes in, and observable is where the events and things come in. Now under the hood, base core sits on top of attribute core, and base observable sits on top of attribute observable. So really what we're going to be talking about are that attribute core and attribute observable, and then there's a sprinkling of other little modifications to how attributes work in base core specifically that we'll interject as we go along. But and then under the hood there, attribute core manages the actual values, so the properties, if you will, inside of a state object, which then removes those properties from the public API. So you don't get into the trap of people setting the property directly on the object, and then stuff breaks elsewhere, right? So it's sort of sequestered away into the state object. And then obviously event target for the sake of firing those change events. So the modules in play are similarly named. Everything is broken down into submodules. This is the YUI way, break everything down into submodules. State is actually subsumed into attribute core. But as I said, we're going to be talking primarily about what's going on in attribute core and attribute observable. So attribute core is, now remember, you're using base, which sits on top of base core, which sits on attribute core. Attribute core is where the API that you're used to is coming from. It has the get method, set method, get adders, set adders. If you haven't used get adders and set adders, I highly recommend it. Get adders is worth looking in the API docs. There's some optional parameters there. It does some cool stuff. And then attribute core brings in the rudimentary support for the ATTRS collection. If you're going to be working directly off of attribute core or off of attribute core with attribute observable, it's worth looking at the code, because the way that it interacts with the ATTRS collection is different than how base does. So, and the code is actually really readable. It's relatively dragon-free. There are a few points that you might get confused about when you read. I know I did. But for the most part, it's actually really pleasant. It's always a joy to read good code, and for the most part, attribute core and the attribute-related stuff is good code. And so the APIs for actually creating the attributes themselves are also in attribute core, obviously. So attribute observable, the primary thing that it brings in is the automatic generation, the publishing and generation of those change events, and then it's going to bring in the event target API as well. So you're on, you're after once, add target for bubbling, and so on. So when we are creating attributes, everything is going to bubble down, trickle down? I'm not going to, whatever. It all goes to add adder. So add adder, however you're going to be adding attributes, either through the ATTRS collection, through add adders, it all goes down to add adder at some point. That's how something, this attribute and its configuration, gets registered in that state object, and it defines how get and set will interact with this attribute. And you can see the signature there. You can look at it up in the API docs. Add adders, pretty self-explanatory, takes the multiple attributes, but it also takes some user values as well. It's worth looking at the signature for that in the API docs or the code as well. And then finally, the ATTRS collection, which if we just had, to step back here, if we just had the add adders method, we didn't have this static, what you would end up doing is you would define your class and say, in my constructor, I'm going to add these attributes for all instances of my class. So you have an object bag inside of your constructor that says these are the attributes and how they're configured. And then after doing that, about 2 minutes later, or maybe while you're doing it, you realize this is the same object for every instance. So I'm going to extract this and make it a static, and then I'm just going to reference that static inside of my constructor. Right? So that's ATTRS. So instead of letting you do that or making you do that and then deciding what to name the static property, we added the magic in to say, if you put it there, we'll do what you expect. Okay. So, another point that's worth noting, I guess, here is that we'll talk about ad hoc attributes a little bit later, but another way to add an attribute to a class is by setting it. So you can set an unknown attribute. Just say object.set unknown thing with a new value, and it will automatically create a registry for that attribute inside of the state object. That doesn't work, though, for construction time. So if you construct something and you pass in a set of user values, then by default, it's not going to create those attributes. So we'll talk about ad hoc adders later. All right, let's go inside. A lot of this is up on the API docs and the user guide, so I'm not going to describe what's going on too much. I'm going to assume that you know their basic function. But the configurations for attributes break down into 2 categories, or 3 categories if you want. The primary category being the value getter and setter. This is the ES5 magic that everything else can basically be implemented on top of or through. So you can do everything else using value getter and setter, with the exception of lazy add. And we'll talk about lazy add. And then these other 2 come from attribute observable for broadcast and from base core for clone default value. And we'll discuss these as we go along. So, value and value function. The thing to note about value and value function, and again, I'm assuming you know what's going on here, obviously, is that assigning an attribute with a value and value function, value or value function, I should say, is the most expensive configuration there is for an attribute. Now, hold your knee-jerk reaction to say, well, crap, if it's expensive, then maybe I shouldn't put in default values for my attributes. You want to put in default values for your attributes. So the question is, what is the cost? Where is the cost? When is the cost happening? And is there something that we can do about the cost? And that's really to the second point here, which the lazy add configuration is meant to spread that cost out across the runtime, or defer the cost entirely. And currently, value function is, even if the attribute is lazily added, which we'll talk about lazy add more next, currently, the value function is always defined at instantiation, or it's always executed, I should say, at instantiation. So that the cost of running that function is going to be there regardless. But Satyan's actually looking at a way to defer the value function execution later. But there's some higher level questions about whether or not that's appropriate to do, because the state may have changed at that point. So we'll see. OK, so lazy add. In the effort to make things, the setup time for attributes faster, so when you're instantiating your classes, you want them to be as fast as they can to create instances, especially if you have a class that you want to create a lot of. And default values are incredibly useful. So if we have an attribute that isn't going to be used a lot, or the attribute isn't going to be used until some later point in the execution of things, then what lazy add does is it says, I recognize that you are configuring this attribute. I'm just going to put that over there. I don't need to actually do any of this setup just now. And then the first time you call get or set, it takes that out of there and says, OK, now I actually need this setup and I need it behaving properly, so it goes through the setup phase at that point. So what you're doing is you're taking the cost of that attribute setup from the instantiation, and you're moving it into the runtime at some later point when it's actually used. And what that means is that you get some attributes that potentially never get set up at all. So that's good, right? It would just be dead code to set that up in the first place. So since you're likely familiar with using attributes from base, this is all happening for free for you because it's set up because base core defaults this lazy add to true. You can override that, as I say, you can override that with this prototype property lazy add adders. If you set that to false or something falsy, then you can, then that means the attributes for that thing will be set up initially on construction. You can also override that lazy add configuration per attribute. So the beware lazy add plus setter we'll talk about on here. Setters. So a point about setter is that setter can be kind of a trap, because when you think about setter initially, it's like, okay, something has changed and now I want to react to that and I want to do this other stuff. But what you need to consider when you're writing your setter is, what master are you serving by doing that other stuff? And the hint is that if you start getting a long setter, you're probably serving more than one master. But for the sake of robustness in accepting a variety of inputs but being conservative in what you put out, and for the sake of maintaining loose coupling with the relationships that you have with other objects, the more logic you put in setter, the more likely you're going to be tight coupling other objects in your system. So widget is actually a good example of this, in that widgets have a central state and they have a UI component. If you're doing UI changes in your setter, then what you're doing is effectively you're taking the model and you're tight coupling it to the view. And you're saying any change here needs to go here. Well, there might not be a view yet. So then inside of your setter, you end up checking to see if it's rendered, and you're building out more logic inside of your setter. When really what you're talking about is there's two masters. There's the pure state, and then there is some other entity, this UI entity, that if the widget is then plugged in with something, or if it's given, or if it has class extensions that override some of that behavior, well, now that second master is changed. So the recommendation for setters are to use it for just one of those two things, either tightly coupled state-related stuff. That would be setting an internal property that's used for calculations. It's not part of the public API, or something like that, building up a little map internally. Or for the more common use case, in my opinion, is for accepting a variety of inputs and then normalizing them internally. It's not for the side effects. That's what I was talking about. That spread of the setter is when you start serving different masters, you get, you're putting side effects in your setters, and that's generally bad practice. So the setter plus lazy add gotcha. If you are using a setter that does do some calculation of stuff and it applies some, it creates a map or it sets a property or something like that on your object, at instantiation, it's not there, because it was lazy added, which means the configuration was just put back there somewhere, and the setter was never run. So then the first time the get or set is run on this attribute, then it runs the setter, it sets up the attribute, it runs the setter, and that little map gets created, right? So now all of a sudden it's working, but why the heck wasn't my map there, or why the heck wasn't my property there? And that's the reason. So if you have a setter that's doing any sort of internal calculation property store or something like that, then either turn lazy add off, or abstract that function, abstract that logic into a separate function and call that function from the constructor as well, or the initializer as well. So that's the gotcha there. Okay. If you have a setter that is doing input type normalization, it's taking in a variety of different values, then don't use a validator, because you're going to need to validate all of those different types in your validator and then also validate those different types in your setter. It's just duplicated code. We provided this, the static invalid value, attribute invalid value. It's also Y.Attribute core.invalid value if you're keeping it low level. And that is effectively like returning false from a validator. And you could effectively, so at the high level, you could consider a validator as sort of like a specialized setter. As I was mentioning, there are those three primary and then all of the others. So you could just always use a setter that does validation in it. But a validator is a little bit simpler. It's run prior to the setter, and it can go a little bit faster, and the cost isn't worth using setter instead of validator. A validator makes more sense. So if you aren't familiar with the fact that the function-related configurations for an attribute can also take a string, then this is really good stuff. So all of the 4 configurations, so setter, getter, validator, value function, you either pass a function reference to them or you can pass a string to them. And the difference is if you pass a string to them, then at runtime, when it is time to execute that, it's going to late bind that string to a function that's on the property, or rather to a function that's on the instance. Which means if you have a class that might get plugged in or might get some class extensions added to it or something like that, they can change that behavior at runtime. Versus if you're passing a function reference in your static configuration, that the resolution of that function reference happens immediately in the static. It gets assigned into that variable, and then when those attributes get set up, that function reference gets stored in the state. You don't have access to that function reference anymore. If you change that function on the prototype, doesn't matter, because the one that was passed into the state happened initially from that static collection. So always use a string. Late binding is great. We like late binding. So it adds a lot more flexibility. Okay, and the last configuration we'll talk about is clone default value, which you can consider to be sort of base's version of a specialized value function. And you can never use clone default value and always use a value function if you want. Clone default value is for that gotcha case of if you're setting up just a basic JavaScript class, you set up a prototype, and on that prototype you had a property which is an object. And that object has various properties inside of it. Well, now every instance that you create of that class has that property. But if you change one of the subproperties of that, it changes across all of the instances because it passed by reference. So this is a gotcha that gets people inside YUI, outside YUI. It's just sort of a JavaScript problem. So when you're setting up attributes, because that ATTRS collection sort of emulates a prototype or a class definition property, like the prototype is a class definition property. So since that's static and you're assigning an object to it, so what the clone default value does is it notices if it's an object. And if it's an object, it says you probably don't want this same object shared by all your instances. And so it replaces it with a clone of that object for each instance. So this is the get you out of that trap for free sort of thing. And this is on by default by base core, and base core is the one that adds it. But you can override it, or you can do what I actually recommend is participating in that abstraction by recognizing that this attribute value is an object. And that's funny. So be explicit about how you want that relationship defined for your instances if you have an attribute that is an object. So either set clone default value to true or deep, or if you want to do just a shallow clone of it, so the individual subproperties can be shared, then you can pass shallow, or false to say, I actually do want to share this one object with all of my instances. The default value is actually the undefined, which checks to see specifically if it's a literal object or a literal array. If it's an instance of some class, then the default behavior for clone default value is to say, it's an instance of something. I'm not going to make any assumptions about this. I'm just going to say everybody gets the same one. So it only does that special clone behavior if it is a raw object or raw array, which is the most likely case. If you have an instance of something, then it probably has a special relationship, like DD manager, for example. You're not going to want to clone DD manager inside of every one of your drags. You're talking about the same thing. All right. So let's come back up to the change events out of the configurations. And I talked about this a bit in the setter section about the relationship for loose coupling or tight coupling. And the change events are that extension of that setter logic where the communication outward happens, where the objects that are in your system start to relate to one another. Instead of having those relations live inside of a setter, then have those relations live inside of the change events. And so keep the setters for state-related, tightly coupled stuff, or values, different types of input values. And then the change events are communicating outwardly. Incidentally, attribute is the reason that we have an on and an after phase in custom events, because we found it to be terribly useful to expose the before moment and the after moment of state changes. And providing the custom event, the actual change event, the previous value and the current value, the incoming pending value, and being able to muck with that incoming pending value to say, I'm going to modify or advise this behavior on its way into the state in some way. All right. So those are two high-level points, but two nitty-gritty points down in the bowels are. So assigning the initial value doesn't fire a change event. You've probably seen that. And then this one here about changing, the change event is published for the first set. This is also a performance-saving thing, and it's similar to lazy add in that event has costs associated with setup and associated with its own APIs. And so we defer the publishing of that change event until the first time the attribute is set to say, now we're going to actually be firing this thing, so publish that event. All right, so I told you we were talking about ad hoc adders. So ad hoc adders complete the abstraction for a certain use case. So the ATTRS collection and the use of attributes in general, you could say, mimic strongly typed classes. Right? So you have an attribute that has a validator on it or has a setter on it, but it's going to behave a very specific way, and this attribute hash defines the state, it defines the attributes for this class, the things that this class deals with. And yes, you can set them dynamically otherwise afterwards, but what if you wanted a more dynamic object that you could configure when you created an instance of it? So so I guess in the property world of things, in the raw JS world, you would say var foo equals an empty object, and then foo.bar equals baz. That mirrors currently over to the attribute interface with new instance of class that has no attributes, and then instance of class that has no attributes dot set some unknown attribute. It is going to set that attribute internally. But you can't say new instance of class with no attributes with an unknown attribute and have it get set up. So it's like saying you can't create an object that doesn't have any properties. Or I'm sorry, it's like saying you can't create an object with an unknown property, because the notion of unknown doesn't exist in terms of raw JavaScript. So the ad hoc attribute sort of completes that or mirrors that. We're saying now this object mirrors or mimics the creation of raw JavaScript objects in some way. So it's participating in the abstraction, the attribute abstraction, but in the way that working with raw objects does. So you can create a raw object and set its properties, and you're just going to create this one on the fly. Or you could create, now, using the ad hoc adders, you can say, I'm going to create an instance of this thing, which is completely ad hoc, using attributes instead of properties, which I define on the fly, and then I'm going to be using that in my calculation. So it mirrors that sort of behavior. But the ad hoc adders specifically addresses the creation phase, because the individual assignment phase happens otherwise, or it always happens anyway. So then worth noting about this static configuration, the non-adders config, that's an array of attribute names that you don't want to treat as ad hoc adders. So if you're doing ad hoc adders, then you might have some, in your constructor or in your initializer, you might look for specific configuration properties in the object that's passed in to say, if I get on, the string on, or a value for on in my config values, that's not an attribute. That's actually a hook into setting up custom event subscriptions. And so if you have some special behaviors that are associated with certain configuration strings that don't represent attributes, then this is a way to blacklist them. All right, so it ends up looking like this. You can set allow ad hoc adders on your class, and then if you want to create a bakery with llamas, then you can do that. All right. So now let's get into the juicy stuff here, which is what does the magic cost, right? There's no such thing as magic in code. We all know that. Magic is more code. So when you are adding magic to it, what you are saying is, I am adding more code to it. And that's fine, right? You create a library to create magic, which makes the problem go away into some sort of abstraction. Now, you don't deal with the individual lines that are associated with, but you do pay the cost of those lines. But the value is in that abstraction. So let's talk about what the costs are. So it breaks down into two primary categories, which is that class creation time and then the use of the API, the get and set costs. And the research on this was kind of painful. All right. So stepping through the attribute setup. The first thing it does is it sets up that state object, and then it takes the attribute configurations and it copies them so that there's no chance of changing them on the fly later after the fact. So it preserves them by copying them. And then attribute core and family, it decides which is the appropriate value to assign to this attribute, either from the user input, or from a value function, or from a value. In that order. So if you provide a user input, that wins. If you don't provide a user input, but it has a value function, that wins. Otherwise, the default value, just the value configuration, wins. And then the lazy adders behave differently. Their setup is lighter. There's less going on there. And they're stowed away in the state, just sort of raw configuration thing, like I talked about. But non-lazy populate this state more fully. And they say, for every configuration that you have in this attribute, that is going to get a property in that state object for that attribute configuration. And then if there's a value associated with it, then it calls set, so that it's going to go through that setter and populate that initial value. So what does it cost? In terms of lines of code and number of function calls, if you have just an attribute core object or something just from attribute core with no events, then no attributes at all, it's pretty light, right? There's 34 lines of code for setup, 9 function calls. It doesn't cost much. Adding one lazy attribute is going to cost an extra 46 lines of code, so you can double that and triple that as you add more attributes on top, and more function calls. Still, the numbers, though, in terms of function calls and lines of code are still relatively low, right, until you start adding lots and lots and lots of things. They're not terribly big numbers. Empty attributes are a little bit more expensive, and they also have the additional cost down here of every attribute property. So the more configuration you add on an attribute has an incremental small cost. But the big cost, as I pointed out earlier, comes from the value, and that's because it's going through the set operation. The set operation, which we'll actually itemize out in a moment, has a lot going on in there. So that's where you see a bump in terms of the function calls and in terms of the lines of code. A value function, it doesn't really change much. So two things I want to point out about this is that the infrastructure, 34 lines of code, not really that expensive. That's not really going to be slowing down your application. When you start adding a lot of attributes in, the 46s and the 56s, they start adding up, because it's never really 56. You're always going to be adding in some sort of configuration for an attribute, so it's going to be a minimum of like 63 I can add. Yes, woo! But also default values are terribly useful. So you're either going to be incurring that cost up front, or if you do a lazy add, recognize that this cost is something that you're going to be paying either now or later. But you get to actually choose when that cost is paid by going lazy add or not going lazy add. value function, it's kind of free. I mean, it's like 3 extra lines of code, another function call. The cost of value function, like the other things like getter and setter, are really coming from the body of the function that you pass in. There's no infrastructure cost to these. They're basically free. So in terms of like those core pieces of the magic, the getter, the setter, those sorts of things, the things that are associated with those functions, the infrastructure to support those is really light. So let's talk about base now. Now, base does a lot more. So it does start the same way. It creates a state object. It aggregates the ATTRS collection up the superclass chain. Now, this is a complicated operation because you're subclassing base. Base provides the initialized and destroyed attributes by itself so that it already has its own ATTRS collection. Your subclass is going to have its own ATTRS collection. And when it aggregates these attributes, and if you are then subclassing and subclassing, for every step in that hierarchy, it takes the ATTRS collection and it finds attributes that are already defined in another class and it merges them together. And then it stores them into an aggregated attribute collection, attribute configuration collection. And then it walks the class chain again, but not via the prototype walk or superclass walk, but it caches the array of classes associated. And it does these 4 things. Now, only one of them is actually related to the attributes. So it does call the class extension constructors prior to setting up the attributes. And then it calls the initializer for the final class itself, or I'm sorry, it calls the initializer for each class as it walks through that list of classes. It calls those initializers. And then it calls the extensions on those classes. So this is, again, for each class, it goes through this same set of operations. Now, I say add adders with a filtered list of ATTRS from the ATTRS aggregate. So when we made all of those aggregated attribute configurations, what happens here is that starting with the final class, it says, what are my attributes? Now, take that total list of attributes that we aggregated up, and now just give me the configurations for those. And the configurations for those will include all of the additional configuration from the other classes merged onto them as it's applied into that class, or into that attribute configuration. And then it calls add adders on those, which goes through that cost that we were describing in the last set. And it's kind of weird. And we've talked about maybe aggregating that just once or calculating that just once or not doing this by class thing. There are some sort of odd edge cases where the sequence by which you're calling the initializers or class extension constructors or class extension initializers might get confused by shared attribute configurations that have some have values set up or something like that. So there's some weird edge cases in there. So then ad hoc adders sneak in there for just the final class, recognizing that the input values that don't map to that finalized aggregated attributes collection then get extracted and then added in separately. And those are just added in as raw attributes with no special behaviors to them. And actually, I don't have the number map, the grid map on this one, because I chose to sleep instead. But suffice it to say, the cost of this is relative to that second number 2 down there, which is as it walks up the chain, it's calling add adders. And then there's the cost of aggregating those adders up the aggregation cost, and then the class instantiation cost and things like that. So what we're talking about here in terms of the cost of attribute doesn't really blow up here. There's some logic that's associated with aggregating those attributes, but a lot of the logic is also associated with working through that class hierarchy and walking through the class hierarchy, calling the extensions, calling the initializers, and those sorts of things. So there's that. So let's now get into the API side of things and get. Now get is actually pretty cheap. I like get because it doesn't do a whole lot. It checks to see if it's lazy and it sets it up if it's lazy. And then it pulls the getter and it pulls the value and it says, do I have a getter? Yes. Well, then return the result of that. Do I not have a getter? I'll just return the value. That's it. And it's really cheap. So we're talking about 10 lines of code, 6 function calls. There's even getting sub-attributes doesn't really incur a lot of additional cost, although we'll talk about sub-attributes a little bit later. And if you have a getter, it's really cheap. It's not costing you anything. Those core things are really cheap. The lazy initialization, it's a big number, but that happens once. You have an attribute that you call get a lot of. You're talking about 10 lines of code. You're not talking about 110 lines of code. So in terms of deferring that cost or spreading the cost out for those attributes across the runtime, then that's where that comes in. So let's talk about set. Now, set I'm not going to do a line by line because Satyen was nice enough to provide this lovely graphic in the user guide, which does a great job of flowcharting out what's happening. So we'll zoom into that. And I'll point out the high points here, which is, again, it has that lazy initialization cost up front if it is lazy initialization. It short circuits if it's a read only or write once. And then it calls get, right? So we talked about get and the cost is associated with calling get. And then, which it won't incur the cost of being a lazy add in that call to get because we've already done that. And then if it's the initial value, it doesn't participate in that right-hand side of the equation where it's firing the events. It's just going into the attribute core stuff. So that would be calling the validator, calling the setter, doing that second check after the setter to see if it returned invalid value, that static invalid value, and then finally storing the state. So set does more, and my calculation puts it at about 80 lines of code and about 20 function calls for just a simple set. And there's, again, that one-time lazy initialization cost. But again, the points about validator and setter being really cheap, same thing holds true here. This one has more of a cost for setting sub-attributes as well. But this is just the attribute side of things. So this is just the attribute core. It's not talking about the events. When we start talking about the events, then the numbers start to add up a little bit more because the generation of a change event is, there's more code that's associated with that. The first call to set, which is going to be publishing that change event, there's an initial cost for that. So if you have a lazy add as well as a first call to set, then you're paying the initialization cost for the attribute and the publish cost for the publish. And then there's a per subscriber cost and there's a per bubble cost. You'll see the per bubble cost is kind of steep right now. The thing to note about this is that we're not talking about attributes here. We're talking about events. And this is the cost that you pay for using the library. So this is just a general thing that the overall performance of your application, whether or not you're using attributes, these are the numbers that are going to be impacting your application. So the good part about that is that fixes made or improvements in performance here then cascade throughout your application and not just in terms of attributes, right? And we'll describe that a little bit more later. So, but do note that there is a per subscriber cost and a per bubble cost here. So now a quick note about the sub-attributes. I do want to say that I'm sorry, because I really pushed for the addition of sub-attribute supported attributes when attribute was first being created, and it wasn't a very good idea. The reason that wasn't a very good idea is that it doesn't maintain that abstraction. It tries to thinly veil the use of object properties and provide a sort of set means of working with them. And then it gets confused in a lot of ways, like working with a getter. For a sub-attribute, you have to parse the object, and then oddly, you have to return an object with a path to that eventual value that you just calculated out. And setter, there's similar oddness there, and there's a lot of extra work that's hard-coded into attribute core, and it was a mistake, and I'm very sorry. Okay, so is it worth it? Here we go. Should you use a property or an attribute? You've waited all this time for this, right? So we've looked at those numbers, and some of the numbers seemed high, some of the numbers seemed low. Hopefully I give a little bit of context to it. But let's break it down into some pros and cons. So we have a property. What's the pros and cons of a property? The obvious pro of a property is that it's fast. It's raw JavaScript, it's terse, right? You're not calling a function, you're just saying a thing. Thing equals whatever. Nested structure is the same, you don't have that sub-attribute problem. And if you are allowed to be in a mandated environment, top-down environment, say, I am only going to write this code for ES5 environments, then there is magic available. If you don't have that, then you're in the cons section immediately, which is the properties are dumb. And they're going to continue to be dumb for years. And the big one is that you can't have a public API that's based on properties move into an API that's based on attributes without breaking your API. And we've actually seen that happen. So looking at the attribute pros and cons, the pros, there are a lot of pros here, in my opinion, maybe because I'm slightly biased, but there's a stable abstraction. You're creating a stable abstraction. It does promote the code organization that you would see in ES5 using the APIs through ES5 as well. The API is consistent if you're using YUI3. YUI3 uses attributes. Your code can look like the code that is in YUI3, and it doesn't start to look different, behave differently. There's fewer expectations for how you interact with the code. The events are there, and events are really, really nice. They're so nice. They are, the code is talking to itself. This is great, right? And the last point there is kind of the big one, is that when you look at things like the impact of the lines of code of function calls, what you're talking about is the sausage, what's inside of the sausage over an abstraction. You consume the abstraction. You pay for the sausage, but you consume the abstraction. I don't know if I should keep that. But what's under the hood can change, right? If it's slow, it can get faster. If it gets faster, you don't change your code. It just gets faster. So on the con side of things, comparatively, they are slow. Just a simple point of fact. Nested structures are awkward. We talked about sub-attributes, and there's more typing. Wah. Okay. So maybe phrase the question more Socratically. It's not necessarily a simple question. Should you use a property or attribute? So maybe you ask yourself these questions instead. Is it going to be accessed a lot, or are you going to be creating a lot of instances? And I mean a lot, because numbers like 100 lines of code or 10 function calls, in browser engines today, you're not going to see it. Until you start really hitting a lot of numbers, you're not going to see it. Will it be public? If you're going to have it be part of the public API, the only place that you can go from a property is towards the magic. And going from a property towards the magic is a broken API. So that's a big red flag. If it's going to be extended, then you can't necessarily define or know for sure that this property isn't going to be interesting to some other class extension or to some plugin. So right now, the implementation of my class, I don't need it to be broadcasting in any way. And if it changes, the only one that cares about it is me in this little case here. But if it's subclass, then maybe that becomes interesting. And would it amount to a micro-optimization? This is where tools like JSPerf come in handy, where you say, using a property, I get 1.6 million operations per second. And using an attribute, I get 100, or I get 500,000 operations per second. That's like 1/3 of the speed. I could be 3 times faster. 500,000 operations per second. Seriously. It's a micro-optimization. So just be wary about that. Don't go total micro-optimization in there. So in my opinion, the reaction to the numbers of saying that's a lot going on, there's a big cost for this abstraction, so I'm shy of that, and I think I'm more comfortable going with something like properties. In my opinion, the question is actually phrased differently. You shouldn't justify the use of attribute instead of using properties. You should justify the use of properties, defaulting to using the abstraction because the abstraction has proven its value. We use get and set. We use the attribute abstraction, and we haven't changed the feature set for it for years because the way that it works right now has proven to be successful, and we like it. And it does what it is designed to do, and it does it very well. So start with believing that the abstraction has value, recognizing the value of the abstraction, and then justify moving away from it. It's less likely to bite you in the ass. So the future is, what does the future hold? So I talked about this a little bit, about the abstraction performance can improve invisibly, and your code benefits from this, and it isn't penalized for it because we're changing the sausage. We're adding turkey and basil or something like that. And that means that what happens is that in the future of attribute, it just gets faster. It doesn't get new features. It doesn't need new features. So far, the API that we have seems to be pretty successful. And if you really need to hack it, there are actually places that you can hack into it. So we can make incremental changes. We can do things like replacing the state object or some of the guts that work with the storage of the value or the association of the getter and setter. In browsers that support ES5 objects, we can use some of that under the hood. That's more of an incremental change. You have this high level of number of function calls that'll reduce somewhat. A more aggressive change that we can make in terms of big performance wins would be compiling the configurations once for a class and just using that for all instances. That would significantly reduce the amount of work paid for instantiating an instance. And Satyen's been doing work into this. The numbers are really good. And we've known about this for a little while. And this is going to be a big change in terms of performance. So instead of having the attribute set up every time you create an instance, that information is known already. And all you have to do is set a value here, set a value there. So in the first case of replacing the ES with ES5 objects, we might be increasing the performance of that set operation. You remember there was 80 lines of code associated with set. And then compiling the configs addresses that concern of creating lots of instances. So you're not paying that initial setup cost for creating lots of instances. And then finally, event optimizations. There are plenty of opportunities to improve how attributes interact with events or even improving the performance of the event system in general. And this improvement, like I mentioned earlier, since events exist in your system in general, not just associated with attributes, performance improvements that happen inside of event optimizations or inside of event, they benefit everything. And so it's like taking the cost of all of the things that we've been talking about and replacing them with kittens making you pancakes. It's, making event fast is just awesome. So kittens and pancakes are the future. And that's all I have, and I'm probably out of time. Yep. Hey, it's noon, but. So since it's just lunch, I can take questions if you want.
So this is a little bit less of a question, more of a statement, but I think it is really important, actually. You showed a lot of lines of code and a number of function calls, but it's important to stress that lines of code and number of function calls does not equal performance cost. The actual performance cost is how long does it take to execute those lines of code and how long does it take to execute those function calls.
Right.
So I would say don't just look at that, but look at the actual time that you're spending in those functions on those lines of code. That's probably a more meaningful metric.
Right.
One more question. Okay, two more.
When it comes to creating a number of large models when you first start an application, is it better off to just simply leave the value undefined or to set it as undefined before you call load on that model? Is there going to be a big performance hit by setting value versus just simply creating the attribute and leaving it blank?
If the initial value is going to be undefined, then it's no different than not having an initial value.
Okay.
Yeah.
I know that in the older browser implementations, the speed of JavaScript access to properties slowed down greatly as heap size increased. And I haven't checked that lately, and like you, I see these fantastic performance numbers when I run tests like at JS tests and all that. But I'm wondering if you've done any research into what the speed really is at, like the memory allocation that you would see at a typical, like, kind of heavy web app.
No, I haven't gone in specifically into the deep performance testing, like as far as what the memory allocations are on the heap and how that changes per property. Since it's at such a low level, it seems like sort of an academic exercise in that since all of the code is going to eventually go down to simple property assignments or function executions, then it's a cost that you're going to pay for whether you're happy about it or not. So how much it's going to affect how the code is actually written, I don't know. I don't think that we tend to code for optimization of heap usage versus convenience of API, sort of thing. Anything else?
Thanks, Luke. I feel smarter already. I just feel smarter. I don't know if I am.
Thank you.